Roughly 2.3 thousand years ago, the circle-obsessed mathematician Archimedes first approximated the value of pi as 3.14, knowledge that was finally revealed to you in the 7th grade. Archimedes achieved this historical feat using a method called exhaustion, which used a series of polygons to get closer and closer and closer to the circumference of a circle. To estimate the value of pi in this activity, we will use the Monte Carlo method, which is governed by the same principles of probability that guide the tossed dice and thumbed cards of the opulent casinos in Las Vegas, Atlantic City, and of course, Monte Carlo. Typically, Monte Carlo methods use computers to simulate and approximate values that are difficult to derive directly. Instead, we will use beans, and I highly recommend using some lentils for a couple of reasons. So they're small, they bounce nicely, and they're also delicious. So when you're all done, you can make yourself a lentil soup. It's very hearty. Okay, anyway, so all of this activity is going to be based around this particular example. What is the theoretical probability that a point chosen at random will be in the shaded region shown in the figure? So taking a look at our figure, we've got ourselves a square with a side length of 8 inches, and inside the square we have what looks to be a quarter circle with a very tasteful shade of, I don't know, maybe lilac or something. It's very nice. So theoretical probability in this case is going to be calculated geometrically, and since this is a plane region where I am selecting my points, I'm going to do it with area. So probability, theoretical probability, is a ratio in which I put the number that I want on top out of everything that's possible on the bottom. And the numbers in this case, again, are going to be areas. So we want basically the area of the purple out of the area of the whole entire squared in order to figure out what the geometric probability is. So let's carry that out right here. Let's see, what color do I have going on? That's not going to work. It's got to be purple to match up my shaded region. Okay, so I'm going to write this as probability, a little p there, where my point is in the shaded region. Right? And then let's conceptualize it first, just as we kind of talked through it. I want the area, the favorable outcome for us is a point in that quarter circle. Draw me a little picture of a quarter circle. Boop, 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 and it's purple. And out of everything possible is the whole entire square here. All right, and as I mentioned, we are talking in terms of area, so let's talk about the areas of each one of these little shapes. So first of all, we start with the area of a circle. So area of a circle, we know as pi r squared. We don't want the whole thing. We just want 1/4 of it. So we could just divide this stuff by 4, which is the same thing as just taking 1/4 of pi r squared. All right, that's going to be pretty easy because we have the radius, don't we? Our radius right here is 8 inches. All right, let's go ahead and calculate some stuff. So I'm going to have 1/4 pi, and my radius here is 8 squared. Shouldn't I put some units on that? Okay, if you insist. Whoops, not you. Inches squared. All right, and then we also need to do the same thing for the whole entire square, which has a side length of 8 inches. How do you find the area of a square? Side length squared, piece of cake. So we're going to put that on the bottom as an 8 squared inches squared. Now, I technically don't even have to calculate 8 squared because I got an 8 squared on the top and the bottom, right? So this 8 squared and the 8 squared, they just divide out. That makes 1, right? It's because it's 64 divided by 64, which is 1. Likewise, the units cancel out too, and this is going to be unitless, which is what we should expect. And what we're left with is the 1/4 pi. 1/4 pi. Usually we write that as a pi over 4 like this. Pi over 4 is the probability that we will randomly select a point and it lands in the purple region. All right, so pi over 4 is a number. Let's think about this for a second. So pi is somewhere around 3, and then I'm dividing it by 4. It's almost around 3/4, which is 0.75. Let's see what the calculator tells us. So it should actually be a little bit bigger than that because pi is a little bit bigger than 3, of course. Let's see. Let's turn on our scientific calculator. Pi divided by, that's multiplication. Come on. Divided by 4. And then we can see that we have a 0.785, blah, blah, blah. Decimals go on and on forever with no pattern. All right, so yeah, it's a little bit bigger than 0.75. Remember that probability as a number is always between 0, which is impossible, and 1, which means it's always going to happen. And this is bigger than half, which is likely, and this is even more likely than that because, well, we're a little bit over a quarter. Well, does that make sense from the picture? Like we take a look at our picture here, it's definitely more than half. It's actually more than 3/4 of the area. We're more likely to land in the purple area than we are in, say, the white area that's right there. All right, so remember that we're trying to use this to come up with the value of pi. So the question is, like, how do we do that? So let's look to the next video to answer that particular question.